In 10.4, we learn about solving polynomials when they're in a factored form. So, back in Chapter 9, we talked about standard form, and now we're going to talk about a new form called factor form. A polynomial is in a factored form if it is written as the product of two or more linear factors. So you can see two examples of factored forms in the following equations there. So first of all, we're going to talk about the zero product property. And we know anything multiplied by 0 will equal 0. That's how we get the product of 0. So what we're going to do in this case is one of these polynomials need to be equal to 0 to make the product of the two of them equal to 0. So we're going to first set x minus 2 could be equal to 0, or x plus 3 could be equal to 0. So very simple here. I'm even going to write it out for you. So x is going to equal 2 here, or x could equal a negative 3. So that's applying the zero product property. So the solutions are 2 and negative 3. So if you check those in the original sentence, you will see that those equal 0. Going to example 2, this time our example 2 says that the square of a product or repeated factor equation is going to equal 0. So this time this would mean, if we followed what we did on the last example, we could also write that squared equation as x plus 5 times x plus 5 equals 0. So this time all we have to do is solve for x plus 5 equaling 0. Take the shortcut this time, so x must equal negative 5, subtracting 5 from both sides. Example 3, this time we have a factored cubic equation because we have 3 equations. The same holds true that to get to our product of 0, one of these has to equal 0. One of these expressions have to equal 0. So the only thing that's different is we now do the possibility of each one of them equaling 0. Whoops. I'm going to stay over here. This is the easiest one. All right. These other ones we have to manipulate just a little bit because we have a coefficient in front of our x. So x is could equal 1/2. In this case, we could do 3x equals 2. So dividing both sides by 3. So x could equal 2/3, or x could equal 1. Oops, I forgot my negative there. All right. So we have 3 possibilities because we had a cubic equation. Now, that part went pretty quickly. Let's go to relating those factors with the x-intercept. Because each one of these expressions we're solving for x, we used to always find the y-intercept, and now instead we will find the x-intercept. So if we're looking at a quadratic polynomial, if one of the statements is true, then all 3 statements are true. So when we're looking at, let's do the different examples here. We're looking at x minus 4 and x plus 3. Okay, those are the factors of this equation right here. Okay, and we'll talk about how to factor them next. So that would mean that I think I'm going to move on to actually showing it to you a little bit more. That would give you a little bit better idea. So if you want to freeze this and read it, you might want to come back to this frame after we've done some in action. Okay, so first we're going to talk about how to sketch a graph of y equals x minus 3 times x plus 2. So, so we're going to first set them to 0. So I'm going to go ahead and I'm going to do my x minus calibration problem. X minus 3 equals 0 is behaving so well, and x plus 2 equals 0. All right, so if I solve both of those, I could be that x equals 3, and x could also equal -2. So we want to find, it says, once we found those, then we want to find the coordinates of the vertex. So we have 2 points. First of all, let's plot these. So, and you'll see I lost some of my graph putting in my directions here, but I think you'll still be okay. So if x equals 3, I'm going to have a point at 3, 0. And if x equals -2, I have a point at 2, 0. And I'm going to go ahead and label those. So I went over 3, up 0. I went over -2, up 0. Now, because this is a quadratic formula, or a quadratic equation, we know that there's going to be a vertex. And that vertex should happen halfway between those 2 points. So what I'm going to do is I'm going to take my answers to my x there, and I'm going to average them. So to average, I have 2 answers, so I'm going to add my answers. And I'm doing that, although it's sloppy. There we go, that's a better 2. I'm showing you with the 2 operational signs, or the integer sign, just to make the point. I'm going to add the 2 points, and then to get an average, since there's 2 of them, I'm going to divide by 2. So if I do 3 plus a -2, I'm going to get 1, and divide that by 2. So I'm going to get 1/2. Okay? Now I need to substitute the 1/2. That's going to be where my x is. So I'm going to write that in here so you remember that. That's where my x is going to be, but I need to know where my y is. So I'm going to substitute this back in to my original equations. So I'm going to, there's my y. Y equals kind of like an input-output. X minus 1/2 times x, oh, sorry. I did that the wrong way, didn't I? Worried about being down there for my calibration. All right, sorry about that. Let's do that over. I'm substituting that in for my x. So x minus 3 multiplied by x plus 2. So now I have, if I went ahead and multiplied those out, I'm going to get, I'm running out of room, so I'm just going to cut the chase. I'm going to get 25/4 as my answer. Okay, so 25/4 would be, again, if I'm, and it's a negative because this first equation was larger. So -25/4. If I'm going to graph it, you can go ahead and change that into a mixed number. So I'm going to go down 6 and about 1/4. We'll say that's about there. And that's going to be the vertex. Whoops, I forgot to go over 1/2. I needed to go over 1/2 for my x and down 6 and 1/4. Oh, it didn't do it very well with the calibration. So I'm going to make sure, and you should do this too, but sometimes it's a little hard for me to see. We're going to go ahead and we're going to label that so Ms. Holman knows where you meant that point to be. Okay, so I got my x from here, and I got my y from there. So I found my x by averaging between the 2 points, and then I substituted that in so that I could find my y-axis. I'm going to use a different color to do my parabola, now that I had some arrows going through there. And there would be my parabola for, a little bit, it's pointy there, but my parabola for that quadratic equation. And remember then, this equation, when I'm referring to it as a quadratic, would have been the equation x squared, right? We'd have outside would be a positive 2x, inside would be a negative 3x, so that would be minus x. And then negative 3 times positive 2 would be a negative 6. There's my quadratic equation that is now shown by that parabola. The next equation is a real life one. And again, I just copied from the book, so this is when you'll want to stop and look at where they got those, the values for. So they gave us the equation here. And it has x and y measured in feet. How wide is the arch at the base and how high is the arch? So you're going to do the same as you did on the last screen. First of all, you're going to solve for the two x's, okay? And you're going to set this, to solve for the x's, you're going to set it to 0 equals negative 0.15 times x minus 8 times x plus 8. So obviously the 0.15, whoops, sorry about that, I want to do that in a different color. I'm off calibration here. The 0.15 is not our zero value, so either this or this quantity needs to be a zero value. That's where they got the x equals 8 and the x, or the x could be equal to negative 8. As you can see, then those are the x-intercepts. Now, how did we find the vertex? We added the two of those together and divided by 2, and that would give us our average of the two of them. And so that's how we, and then we found, so that answer would be what's x plus a negative x would have been 0, and then we would divide that by 2, and then we would then substitute that back into this equation here. That's how they found their vertex. So you find, I'm going to just write in your little notes here. First you find the average, then you substitute into original. So the same as we did last screen. And that concludes lesson 10.4.